We're going to start by introducing a concept called sets. And you may have seen sets a little bit before, but we're going to really formally define them here and show lots of different types. So we tend to think or tend to place things in categories, which allow us to order and structure the world. Mathematicians call such collections sets. A set is a collection of objects whose contents can be clearly determined. So that idea of clearly determined is actually important. So it should be clear and well defined. There shouldn't be confusion about what is in the set. And objects in a set are called the elements or members of that set. Like I said, a set must be well defined, meaning that its contents can be clearly determined. So, we clearly understand what is in a set or is not in a set. And we're going to look at some examples, so I think this will make a little bit more sense. Now, when we name sets, we typically use capital letters, so we'll use a single capital letter. For instance, we can use the capital letter W to represent the set of days of the week. We can describe sets in different ways. So one way we can describe sets is with a word description. So for instance, we can describe the set W as a set of the days of the week. So here, we're describing W in words, right? So we're just using words to describe that W represents all the days of the week. A second method, which is much more common, is called the roster method. The roster method actually lists the elements in the set. And what we do when we're talking about sets, we use this specific notation here, these kind of curvy brackets, they're called braces. When we do have sets, you want to be careful. We do not use parentheses. So no parentheses, no brackets like this. We use these squiggly ones called braces to define a set. So that's really important that you use the correct notation. So if W is the days of the week, we can represent W as Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Notice again, we use those squiggly braces at the start and the finish of the set to show what is contained. And I do not put extra words in there. So don't put the word and, like Saturday and Sunday, because then you're saying the word and is part of the set. And is not a day of the week. So we only put exactly what is in the set. And we can use commas to distinguish the different elements or members. Order is not important. So when we do list a set, I could put them in a different order. So if I wanted to write my set as Tuesday, Friday, Saturday, Monday, etc., that would be fine too. So ordering does not matter, although you'll notice we usually put things in some sort of logical order. It's not required. With sets, though, we do not like to repeat elements. Sometimes you may see sets that have repeated elements, but it really can be simplified further. Sort of the idea of fractions, right? If we can simplify or reduce fractions, we do. So with sets, we don't like to have repeated elements. For instance, I don't need to write the word Monday twice, right? I can just do the days for 1 week. I don't need to keep repeating the days over and over and over again. So let's look at some examples here. So the first one, and I'm just taking these from your text as well, says to write a word description of the set P equals Washington, Adams, Jefferson, Madison, Monroe. So the elements in the set are Washington, Adams, Jefferson, Madison, Monroe. Now, if you're good at U.S. history, you may recognize that these are the first 5 U.S. presidents. So that's what the set contains here. If you're not as good at U.S. history, you may be kind of at a loss of what could this be, right? But they do actually have in common that they're all presidents, and why they're using P here, and then the first 5 presidents of the U.S. So we could say something like, set P is the set of the first 5 presidents of the United States. Okay, so we're just phrasing that set in words. Let's say C is the set of US coins, I should say coins here, with a value less than $1. Express this set using the roster method. So they've given us the example in the word form, and we're going to write it in the roster method. So we're going to list those elements, and we're calling it C. So I'm going to write C equals, and again, I'm going to use those squiggly braces to show my elements in the set. The roster method means to actually go ahead and list them out. So list out all those elements. So I need coins with value less than $1. All right, so think about the coins that we have. Obviously a penny, and we're talking US coins here. A penny has a value 1 cent, so that's less than $1. A nickel is worth 5 cents. A dime is worth 10 cents. A quarter is worth 25 cents. Now, most people would stop here. There is technically a $half, although we tend not to use it in everyday currency. But there is a coin. It's larger than the quarter, so it's a good sized coin if you've never seen it before, much like twice the size of a quarter coin, kind of. And it's silver, and that is 50 cents. So that's your $half coin. Now, there is a dollar coin as well. Again, it's not really used so much in everyday currency, but these are strictly those that are less than $1. So these will be all coins in US currency less than $1. And again, this is the roster method. So we're physically listing the elements in that set. Now, there's a third way that we can write sets as well, and this is called set builder notation. And realistically speaking, we tend to use either the roster method here or set builder notation. Again, we could use that word form to the word description. It's just not used as often. So we tend to use something a little bit more formal than the word description called the set builder notation. And you may have seen this if you've done other algebra classes. So set builder notation looks like this, okay? So you do have those squiggly braces on either end, and then it typically always starts with a variable. So you're going to have a variable here. Usually we use x, but it doesn't have to be. It could be a different variable. And then this vertical line means such that. So you're in set builder notation, you're always going to see some sort of set where you have a variable and then a vertical line. And then you're going to actually fill in what that set represents next. So you can see we are kind of using a version of the word description here, but we're putting in a more formal notation. So we're saying W is X, such that X is a day of the week. So that's called set builder notation. So let's take something in set builder notation and then write it as the roster method. Again, those tend to be the two most common ways that we write sets. So A is the set X, such that X is a month that begins with the letter M. So think about all of our months in the year. We have January and then February. Next, we have March, which begins with M. We have April, we have May, and then June, July, August, September, October, November, December, right? So we go through all of our different months. There's only 2 that begin with M, so that's the end of our set. So this is your set builder notations. Again, it's a little bit more formal. And then you have your roster notation. Now, there's one specific set I want to talk about, and that's called the empty set or the null set. And you'll hear both terms used interchangeably. So for instance, think about these sets. The set X, such that X is a fawn that speaks. Now, a fawn is a baby deer. So do we know of any baby deer that actually speak in the real world, right? We're not talking about Bambi in the movies, but do we know any deer that speak? No, I don't know any deer that speak. Or this one here, X, such that X is a number that's greater than 10 and less than 4. So I have an and there. So do I have a number that is greater than 10 and also less than 4? No, I can't think of any numbers that fit that description. So these two sets have no elements or members. So neither set contains any elements, so they are empty. So we say that these sets are the empty set or the null set. So the empty set, also called the null set, is a set that contains no elements. We can represent the empty set in a few different ways. You can literally just write it like this. So you have a set with it and it's totally empty on the inside. That's one way to express the empty set or the null set to show that there are no elements. Or you can use this notation here, which is like a circle or a zero with a line through it. That also means the null set or the empty set. Now, to clarify, this is not an acceptable notation here for the empty set. Because what you're saying here is this is actually the set that contains the symbol for the empty set. So this set actually has something in it. It has the symbol for the empty set. I know that's a really weird idea to grasp in concept. The idea of sets I think is pretty simple, but a lot of the notation can get a little tricky, a little weird. So again, this is not the empty set. This is a set that has one thing in it, which is the symbol for the empty set. So that's not what we use here. We use this for the empty set or this without the parentheses. So which of the following is considered the empty set? So the first example I have is the set that contains the number 0. This is not empty. The number 0 is not empty. 0 is a number, it's an element. So this has one element, right? It has the number 0. So it is not empty. This is not the empty set. Here we have the number 0. This is not even a set because it doesn't have those little squiggles around it. So if it's a set, it has to have those little squiggles, those braces. So this is not the empty set. It's just a number. It's not even a set. Here, x such that x is a number less than 4 or greater than 10. Now be careful here. This one has the keyword or in between, not and. So the set consists of numbers that are less than 4 or greater than 10. So for instance, the number 1 or 2 or 3 could all be in there because they're all less than 4. Or the number 11, 12, etc. could be in there because they're greater than 10. So this is not empty. This has lots of different numbers. Here, the set x such that x is a square with exactly 3 sides. So think about a square. You know a square always has 4 sides. There is no such thing as a square with 3 sides. So there are no elements in this set. So this is the empty set.